Okay, welcome to another marathon series. Today's topic is basically a part of representation of data for S1. So, if you're giving your S1 exam, uh, this marathon will be useful to you. A lot of people are actually confused about this topic. This topic is taught with two different names. If you followed my videos, I generally use the word coding of data to explain this topic. There is another idea called the assumed mean. So it's the same thing. Uh, it's just important to know how to solve these questions and what exactly is happening. The name actually doesn't matter. So what I'm going to do is I'm going to try to do as many questions on this topic as possible. I'm going to scroll through questions. I'll skip over some questions and do the rest of them. So starting with this first question, it says the length of time t minutes. So my actual variable is t. Taken to do the crossword puzzle in a certain newspaper was observed on 12 occasions. So n is 12. The results are summarized below. So instead of the data for t, I have data for t minus 35. What has happened is whoever collected this data subtracted 35 from each of these observations and then calculated the sums and so on. Okay, so they've given you these two data points. It says calculate the mean and standard deviation of these times. So I'm asking you to calculate the mean and standard deviation for t. Times is t as illustrated in the first sentence of the question. So if you followed the videos, what I generally say is that you have to remember these two ideas, and that simply is that if you use the adjusted values to the calculate the mean, it's basically the mean of t minus 35. So the individual observations can be are not there. I just have the adjusted numbers. So what I can use is I can use this equation to basically solve for the mean of t. So let's call that t bar. That's what I'm looking for. So that's the first thing that I have calculated. Minus 35 remains as it is. If I'm calculating the mean of t minus 35, I have to use the mean of I have to use the sum of t minus 35, that's minus 15, and mean is just simply sum divided by n. So what I'm going to do is I'm going to divide this by n, and that's 12. So t bar then comes out to be, let me calculate this quickly, that gives me 33.75. So that's t bar. Similarly, when I'm trying to calculate the standard deviation, now standard deviation is derived, so I'm going to say that variance of t minus 35 is the same as variance of t. The variance does not get adjusted. That is something that I explain in detail in the videos on the lecture. So please go back and watch the lecture if you haven't already, and that should give you a clue of what is happening here. So if I want to find the standard deviation of t, I'll keep the variance of t as unknown. I want to say that this side remains as it is. On the other side, I'm going to use the variance formula. Now the variance formula is typically sum of x squared divided by n minus the mean squared. But I don't have the original values, I have the adjusted values. So I'm going to calculate the adjusted variance. I'm going to say 82.23, the squared values divided by 12, and the mean of the adjusted value. So the mean of the adjusted values is minus 15 over 12, as is written in the line above. So that is the variance of t minus 35, and by the rule, it's also equal to the variance of t. So that gives me 5.29. That's variance of t. And if I take a root, that gives me 2.3. So standard deviation is root of 5.29. So I'm going to use these two equations to solve all the questions that come up on this topic. That was the first question. You can follow the years, open up the years, and then solve them, and then look at the solution if you want. I'm going to quickly try to do as many questions as I possibly can on this topic. So that's another question then. It says Esme noted that test marks x of 16 people. Now remember that the original variable is x. There are 16 people, so I'm going to write n equals to 16. She found that the sum of the original marks was 824 and that the standard deviation of the original marks was 6.5. Calculate the sum of x minus 50 and sum of x minus 50 squared. So I'm asking you to do an adjustment on all the marks and then calculate the sum for me. So what I can simply say is that again I'm going to use that same inequality. I'm going to say that the mean of x minus 50 is the same as mean of x minus 50. Now the mean of x can be calculated here, 824 divided by 16. So that's something that I've calculated quickly. What I need to find out is sum of x minus 50. So I'm going to say that if I was calculating the mean of the adjusted values, I would use the sum of the adjusted values and divide it by the number of observations. So that gives me 16. Now this is simply just cross multiplying. So when I cross multiply 16 like that, this remains 824 and this becomes 15 to 16. I can do this all on a calculator. I don't really need to show you working for this. Just to make things simpler, that's what I've done. So that's 24. Now if I need the sum, what I need to do is I need to use the idea of the variance. So I'm going to say that the variance of x minus, let's just do this at the bottom. Variance of x minus 50 is the same as variance of x. Now, can I calculate the variance of x? Yes, I've already told you, and the standard deviation of x was 6.5. So I don't really need to apply a formula. I can just say that this is 6.5 squared, since that's the variance. Now, if I was calculating the variance for the adjusted values, I would use the sum of the adjusted, I would use the square of the adjusted values, divide that by 16 since there were 16 people, and I would use the mean of the adjusted values, which is basically 24 divided by 16 again. 24 because that's the sum of the adjusted values. So 6.5 squared plus 24 squared divided by 16 squared into 16. That gives me, when I cross multiply and add and subtract, that gives me 712. So I've gotten both answers that are correct. Then it says one person did the test later and her mark was 72. Calculate the new mean and standard deviation of the marks of all 17 people. So I'm not asking you to make an adjustment in all the marks right now. What I'm just telling you is that there was a sum original and that got changed because a new person came in. So what I'm going to say that the new sum is basically 824 plus 72. What do I get? I get 824 plus 72 gives me 896. So the new mean would be 896 divided by 17. That gives us 52.7. New variance. So let's calculate the new variance. Now that's something that I need to work on because this is 3 marks. There is a bit of working here. For the new variance, I need the new x squared divided by 17, and then the new mean, so 896 divided by 17 whole square. Now the problem is that I don't know the new x square, and I don't honestly also know the original x square. So what am I going to do? There are two ways of actually doing this. I could use this idea, but that's more complicated. So what I'm going to do is I'm going to do a little bit of calculation to work out backwards what the original sum of x square was. How am I going to do that? I'm going to use the variance formula. I'm going to say that 6.5 squared was basically sum of x squared divided by 16 minus 824 over 16 whole square. That was the original x square. That's what I've written. into 16. I get sum of x squared as 43112. So that's the original sum of x squared. When I'm calculating the new variance now, it's simply 43112 plus 72 squared divided by 17 minus 896 divided by 17 whole square. That gives me 63.03. Let's take a root and see if I get the correct answer. Yes, I get ST as root of 63.03, 7.94. You can see the calculations now. Moving on. That's another question now on with the adjusted values and assumed mean and all those things. It says a sample of 36 data values, say n is 36, and gave this and that. So I've again told you the adjusted sums and the adjusted squares. Find the mean and standard deviation of the 36 values. So I'm asking you for the mean of x. So I'm going to first say that the mean of x minus 45 is simply mean of x minus 45. So I get x bar. That's what I'm trying to find. Here I'm going to calculate the mean. Minus 148 divided by 36. So I get minus 148 divided by 36 plus 45. So I get x bar as 40.9 basically. Then for the standard deviation, again, I'm going to say that the variance of x minus 45 is the same as variance of x. And there's an adjustment there. So that's what I'm trying to find. I'm trying to find the variance of x. So I'm going to let that remain as it is. On the other side, I'm going to use the variance formula and calculate the numbers. 3089 divided by 36 minus 148 over 36 squared. So I'm going to calculate the variance of the adjusted values and say that it's going to be equal to the variance of the original values. Okay. Then again, it says one extra data value of 29 was added to the sample. Find the standard deviation of all the data values. Now, this is a similar question to what we did earlier. Uh, Again, this is something that I could essentially do from here only. There is another way of doing it, and that's what I'm going to illustrate in this question. Now, you see one extra data value of 29 was added. So this value is actually a value of x. Here I have the sums of the adjusted values. So can I say that the adjusted value that was added to the data set was 29 minus 45, which was basically minus 16. So this sum goes up by minus 16. So the new sum of x minus 45 is basically minus 148 minus 16. So minus 148 minus 16. What does that give me? Minus 164. Okay. And what about the sum of x minus 45 squared? So can I say that that is basically 3089 plus minus 16 squared? 3345. So what you need to understand is these are the new sums. I would also have done this question the previous way, the one that I did before this, where I was again taking an additional data value, but this is the other way of doing the question, so I'm just illustrating both ways of doing the question. So then I can say that if I want to calculate the variance of x, it's basically the same as variance of x minus 45. So then this becomes 3345. I have a new data value, so that's 37 data values and minus 164 over 37 squared. So 3345 divided by 37 minus 70.76, 8.41. So that's about this question. You can look at the solution if you want. I'm just going to scroll up so that you can see it. You can follow the years and look at the questions as well. Taking up more questions on this. Here is another question. It says Swati measured the lens x centimeters. So the original variable is x centimeters, n is 18, and found that the sum of x squared is this, given that the mean. So x bar is basically 58 over 9. And find the values of x minus 5. So Swati is asking you to calculate the adjusted values. So I'm going to say that the mean of x minus 5 is the same as mean of x. I always start with this original equation. Why? Because it tells me what I need to find and what I already have. So this is what I already have, 58 over 9. Now, if I want to calculate the adjusted values, I want the adjusted sum. That's what I'm looking for. That's unknown, so that's there. And divided by 18. So 58 divided by 9 multiplied by 18 gives me 116. Then if I want this squares, I need to use the idea of the variance. So variance of this is equals to the variance of that. Swati hasn't told you the standard deviation or the variance of the original values either, but she's told you the sum, which is 967 over 18 minus the mean, 58 over 9 whole square. On the left hand side, I don't need the variance of x minus 5, I just need one of the components, which is x minus 5 whole square. So I'm going to keep that as the unknown. I'm going to apply the formula on the left hand side as well. I'm going to say that this is 18 minus the adjusted values, the sum of the adjusted values divided by the number here. So the left hand side has the adjusted values, the right hand side has the original value. So I'm looking for an adjusted value. So that's the unknown in this question. I can simply solve this. I don't need to do a lot of calculations. I can just say that this becomes 967 over 18 minus 58 over 9 whole square plus 116 over 18 whole square. So, and then multiplying by 18 gives me, I just need to check these answers. I have a feeling that they're wrong. Oh, I missed. My bad. I missed the 5 here, which is why the answer is wrong. Okay, this should be something different. It's 26, that's correct. And then this also gets adjusted. A small mistake could cost you dearly here. 26. Okay, yeah, that's the correct answer then, to 57. So I made a small mistake writing the question at the start, so that was a mistake. Moving on. That's the question. It says the height x centimeters of a group of 82 children. So 82. I have the adjusted values, and this is the original. It says find the mean height. So I know that the mean of x minus 130 is the same as mean of x minus 130. So minus 287 divided by 82, x bar so x bar is basically then 126.5. Then I'm going to ask you to calculate the sum of x minus 130 whole squared. So I'm going to use the idea of the variance. Then variance of x minus 130 is the same as 130 basically squared variance of x. So that's basically 6.9 squared. Here I start plugging in the formula. I don't know the sum, that's what I'm looking for, so I'm going to keep that as the unknown. Divide that by 82 minus. I'm going to use the adjusted mean here. So that should give me the answer then. I'll add first 6.9 squared plus 287 divided by 82 squared into 82. So that gives me sum of x minus 130 squared as 4908.5. So that's another question. I think this is one last question. Two, in fact. Let's quickly get through these. It says the monthly rental prices for 9 apartments in a city are listed and are summarized. So this is the original variable that I have. There has been some adjustment in the values. I don't know what adjustment. It says the mean rental price is 2205. The first is asking you to find the value of C. So I'm going to say that the mean of x minus C is basically the same as mean of x minus C outside. So this becomes 1845 divided by 9 equals to 2205. That's given in the question minus C. So 1845 divided by 9, 2205 minus answer. So C is basically 2000. Then it says find the variance. So what I just need to do is I need to plug in the formulas. Want to find the variance of x, so I'm going to keep that as the unknown. I have 477450. So 477450 divided by 9 minus 1845 divided by 9 whole square. That's variance, yes. Okay, then it says another apartment is added to the list. The mean monthly rental price is now 210220.5. Find the rental price of this additional apartment. So that's pretty simple. If I knew the old mean, I could just work backwards from there, calculate the sum of the original values, and then sort of find the new mean. So I think that's a very simple question. So the mean was 2205. I don't know the original sum, so I'm going to say that that was sum of x. So sum of x was basically 2205 multiplied by 9, I get 19845. And so new sum is basically 19845. Okay, I don't know the new sum. Let's call that 19845 plus x. Okay, I know the new mean 2120.5. So I'm going to say that the new mean is basically 19845 plus x divided by 10 equals to 2120.5, and then add, subtract, and then get my final answer. 1360. So that solves the question. The last one, it says Tn measure the length x. So the original variable is x. Of 20 people in his class, he found that sum of x is this and the standard deviation of x was that. For calculate x minus 45 and x minus 45 squared sum, the sum of x minus 45 squared. So I'm going to again write my ideas as it is. You've seen in the questions that I've used the same idea every time. That's because this question becomes easier if you start with the same idea and then figure out what the unknown is. So can I calculate the mean? Yes, I can calculate the mean. So that's 1218 divided by 20 minus 45. I don't know the sum of x minus 45, but I can apply the formula and say that this is divided by 20. So 1218 divided by 20 minus 45 multiplied by 20. So sum of x minus 45 is basically then 318. For the variance of x minus 45, I'm going to write variance of x minus 45 as the same as variance of x. That's 4.2 squared. That is unknown, so sum of x minus 45 squared divided by 20 minus the mean of these values, so 318 divided by 20 squared. So on the left hand side again adjusted values, on the right hand side the original values. 4.2 squared plus 318 divided by 20 squared. So this gives me sum of x minus 45 squared as 5409. You can find more questions in the recent past papers. All of those questions will solve with exactly the same idea. You might come across at least one question that might be a little different, but that's not impossible to solve where you have data values, for example. I would probably find that question here as well. If you just go back and see if I can find that question, and we can do that as one last question before this marathon ends. Yeah, that's the question. Um, the different thing about this question is that you have the original data values in the form of a raw data. So when I'm asking you to basically calculate sum of x minus 62, what you can do is you can these are the values for x. You can construct a table for x minus 62. What would that table look like? You subtract 62 from each of these values that are given to you. So 62.7 minus 62. So that leaves me with 0.7. That leaves me with minus 2.4. 59.6 minus 62. Yeah, that should be minus 2.4. Okay, that leaves me with 2.2. That leaves me with minus 0.5. So I'm subtracting 62 from each of these values. 6.3, 4.9, 0, and 0.3. So those are the adjusted values. What do I need to calculate? I need to calculate the sum of these values in the first part. So I'm going to add up all of them. 0.7 minus 2.4 plus 2.2 minus 0.5 plus 6.3 plus 4.9 plus 0 plus 0.3. So that gives me 11.5. Then what I have to do is I have to square all of these values and then add them up. So what basically I'm saying is 0.7 squared, all of these squared and add it together. So adding all of these up, squaring them and adding them up. So you can't just square the sum, you have to square the individual values and then add them up. So I get 75.13. Then in part 3 it says find the mean and variance of the speeds of the 8 cars. So you could use the original values for the mean or you could use the adjusted values for the mean. That's your call. If you're using the adjusted values, you'll have to say that mean of x minus 62 is the same as mean of x minus 62. So I could just say that this is 11.5 divided by 8. Mean of x is unknown, minus 62. So 11.5 divided by 8 plus 62. That gives me it's part 3. Then for the standard deviation variance of x minus 62 is the same as variance of x. So I'm going to say that that becomes 75.13 divided by 8 minus 11.5 divided by 8 squared equals to variance of x. So 7.32. I could have just used these original values as well to do the same calculations and they would have given me the same answer. You can try that out and tell me if that works out. If it doesn't, please leave a comment. If you watched this video, please make sure to like and subscribe and press the bell icon for future updates. Thank you.